Okay. So today we're talking about graphing systems of linear inequalities. So much like what we did yesterday, just graphing linear inequalities. Tiana, will you hit the lights for me, please, and thank you. Much like we did yesterday, an inequality has two variables whose graph is a region of the coordinate plane, right? That line that we draw is called a boundary line. If the line is solid, that means that a solution is a point on if the line is solid, that means that a point on the line would what? Is it a solution or is it not a solution? Okay, let me go right here. Let's look at something. So when I solve for this, I get y is less than 5x plus 2. So I begin at 2. And I have to go up 5 to the right one or down 5 to the left one. This is a dashed line, correct? So if I ask you, and I'm going to shade below. So if I said to you, pick a point in the solution set, can a point that's on this dashed line be a solution? Why not, Aiden? Because it's a dashed line. So if I had a solid line, my question was, well, what if I have a solid line? Down 1 over 2. What if my line is solid? Okay, if I have a solid line and I say, hey, I think that this is possibly a solution. Is a point on the line a solution when you have a solid line? Yes. Okay. So I want to make sure you remember that. I want to make sure you understand that. So each point in the region is a solution of that inequality. So remember that if we have a less than or greater than symbol, both of these are going to be represented by dashed lines. And less than we shade below, greater than we shade above. Whoops, did you see how I'm spelling that? Man, Dina. Less than or equal to, solid, shade below. Greater than or equal to, solid, shade above. So I'm just going to make up some inequalities. So for this first one, I'm going to say y is less than negative 2x. So my slope is negative 2. I begin at 0. So if I were to do that, I would start here, go down 2 over 1. This is going to be a dashed line, right? Dashed line, shade below. If I have a greater than symbol, I'm just going to make some lines up. Greater than, dashed line, shade above. Dashed line, shade above. If I have a less than or equal to, my line's going to be what? Solid or dashed? Solid. Shade below. Greater than or equal to, my line is going to be solid, shade above. So this is just kind of a reference of how you shade with the symbol. So we know that from yesterday's lesson. Today we're going to have two inequalities. We're going to have a system. And so the solution set is going to be in the overlapping regions. And the overlapping regions are going to be visible if you use two different colors. I want everyone to pick their head up, okay? Laying your head on your desk is not being with me. I need you to be present. All right, so to do this, we're going to make sure each equation is solved for y. We're going to graph based off of our slope and our y-intercept. We're going to make sure that we show dotted and solid lines. We're going to shade each inequality. We're going to use two different colors. And the overlapping region is going to be the solution set. It'll show up as a different color or it'll be darker. So for my first example, this first equation in my inequality system, y is greater than or equal to negative x. What is my slope and what is my y-intercept? I'm going to call in students, okay? So slope, Jaden. Slope, the first one, Jaden, the one above it, the slope. Think about the number in front of the x. -1, good job. So that's going to be -1/1. Y-intercept, Seamus. What's the plus after that negative x? Plus what? On that first inequality? 0. Yeah, good job. Solid line or a dashed line? Bailey, solid line or a dashed line? Good job. Shade above or below? Amalia, shade above or below? Above, perfect. So I'm going to begin at 0, and I'm going to go down 1 to the right 1. Down 1 to the right 1. This is going to be a solid line, and I'm shading above. When I look at the second inequality of this system, my slope and my y-intercept are, let's see, Travis, what do you think my slope is of the second inequality? -4/3. Yeah, -4/3. That means I'm going to go down and to the right. What is my y-intercept, Kaden? What's my y-intercept? 0. Solid or dash line, Uriah? Solid or dash line? Shade above or below, Jansen? Shade above or below? And you know what, Jansen, you weren't here yesterday. I didn't mean to put you on the spot. Are you okay? Do you feel like you can answer that, or you want me calling someone else? So if you look at the symbol, it's a less than symbol. And here's how I remember the less than or the greater than. Because I'm sure at one point in your math career, someone told you that the alligator eats the larger stuff, and that doesn't help you remember what the symbol is called, right? So here's how because I was one of those kids, right? And I tell you guys all the time, I struggle with math. We read math from left to right, just like we read a book. So when I first look at this symbol, when I first look at it, the small end appears first. Do you see that? So that means that this is a less than symbol. Where when I first look at this symbol above it, the large end appears first. That means greater than. So this is going to be a less than, which means I shade below. And that's how you tell the difference of those. And had someone not ever explained that to me, I would still try to figure out the whole alligator thing, right? So I'm going to begin at 0. And from there, I'm going to go down 1, 2, 3, 4 to the right, 1, 2, 3. I'm going to keep doing that. 1, 2, 3, 4 to the right, 1, 2, 3. I'm also going to go from 0 and go up 1, 2, 3, 4 to the left 3. 1, 2, 3, 4 to the left, 1, 2, 3. And this is going to be a solid line. And I'm shading below. So hopefully you see when you shade below, the solution set for your inequality is very small. It's just that little sliver of what has maybe turned into like an orange color right here. This is the only area where an ordered pair, would make both inequalities true. So if I were to select this point right here, this is the ordered pair, -1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6, 7, 8. So if I chose the point -7, +8, it would make both of these true. Well, I don't believe you. I want to check. Okay, so let's check. So if I say y, which is 8, sorry, I'm going to plug in 8 and negative 7. So y is 8 is greater than or equal to negative, and my x value is negative 7. So what is the opposite of negative 7? Positive 7. Is 8 greater than or equal to positive 7? So that's true, correct? It's a true statement. Now let's plug in negative or 8 for my y and negative 7 for my x. So 8 is less than or equal to negative, let's see, 4/3 times, that's not a negative 4/3, sorry, times a negative 7 over 1. So 4 times 7 is 28. So 8 is less than or equal to negative 28 over 3. So what is a negative negative? Our opposite of a negative. You guys see how I have two negatives there? Positive. So is 8 less than or equal to a positive 28 over 3? Yeah, because how many times does 3 go into 28? Well, you can use your calculator. What's 28 divided by 3? 9.3 repeating, right? So it's greater. 9 is greater than 8. So that's also true. Okay, we're not going to check every single one, but I want you to understand what we're doing here. So the solution region is going to produce a ordered pair or multiple ordered pairs that work for both inequalities. Let's look at our second example. So we have to solve for y. We have to solve for y. So our first inequality, 2y minus x is less than negative 6. I'm going to solve for y. What do I want to do first? Add the x. So 2y is less than x minus 6. Almost got y by itself. What do I need to do? Last step. Good job. Divide every term by 2. Y is less than. So remember there's an imaginary 1 in front of that, like an invisible 1 in front of the x. We don't write it, but that gives me the fraction 1/2. Y is less than 1/2 x, and negative 6 divided by 2 is negative 3. So let's write down the important things. What's my slope of this line? 1/2. Good job. What is my y-intercept of this line? Negative 3. What is my shading, above or below? And is my line dashed or solid? What do you think, Cameron? Dashed or solid? Dashed. Shade above or below? Delilah, shade above or below? Below. Good job. Okay, let's solve the next one. Let's get the next one solved and then we'll graph them together. So my next inequality, 4x minus 3y is less than 12. All right, Zan, what do I have to do first? If I'm trying to get y all by itself, what do I need to do first? Yeah, I have to subtract 4x from both sides. So negative 3y is less than negative 4x plus 12. Next step, Ashton, what do you want to do? So that's a times. That says negative 3 times y. What's the undo of times? Divide. So how about divide by negative 3? Divide by negative 3. Y is less than. A negative divided by a negative is a positive. Good job. And 12 divided by 3 is so negative 4. What is my slope, Carla? 4 over 3. Perfect. What is my y-intercept, Aiden? Oh, we are supposed to change the sign. Good call on that. Good catch. That should be a flip-flop. Thank you. Aiden, you're my hero today. Okay, y-intercept. Anyone? -4, good job. So it's greater than, which means solid or dashed, above or below. Anyone? Dashed and above. Okay. So our first one, begin at -3. Thank you, ma'am. I'm going to go up 1 over 2. Up 1 over 2. It's going to be a dashed line, so I need to give myself a couple more points. I'm also going to go down 1 and to the left 2, down 1 and to the left 2. So I feel like I can do a nice job of graphing my dashed line here. Remember, you want to put arrows on your lines, and this first one is going to be a shade below. Shade below. My second graph, my second inequality, I'm beginning at -4. I'm beginning at -4. And this has a slope of up 4 over 3. So I'm going to go up 4 to the right 3. I'm going to do that a couple of times. Up 4 to the right 3. I'm also going to go down 4 and to the left 3. Dashed line again. But this one is a shade above. This one is a shade above, right? This one is shade above. So my solution area is anywhere in this range, right? I can pick a solution from anywhere over here in that little zone. We ready to do example number 3? Yes or no? Okay. Example number 3. So for example number 3, what kind of a line is this? Y is less than or equal to 5. Yeah, this is just a horizontal line. So I'm going to have a horizontal line. It's going to be solid, and I'm going to shade below. So I'm going to go to where Y is 5. 1, 2, 3, 4, 5. And I'm going to make this nice, solid horizontal line. And I'm going to shade below. So it's definitely nicer to have horizontal and vertical lines, right? Less counting. Easier to think about. My second inequality, I have to get Y all by itself. So I'm going to solve for Y. What should I do first to try and get Y all by itself? What's the first thing that I need to do? Yeah, add 3 to both sides. So Y is less than 1/2 X plus 3. So I'm going to begin at 3. My B is 3. What is my slope? 1/2. My slope is 1/2. Is this a solid or a dashed line? Dash. Am I going to shade above or below? Below. So let's see. I begin at +3. I'm going to go up 1 and to the right 2, up 1 to the right 2, up 1 to the right 2. I'm also from 3 going to go down 1 and to the left 2, down 1 to the left 2. So I can get some nice dashes in there. Dash line. shade below ma'am. Yeah. If that one's not working, throw it away. So this inequality system has a large solution area. Do you guys see that? Like this has a really significant overlap on our graph. So anywhere in that orange space down here, anywhere in that orange space is a solution. Okay. We're going to skip example 4. And I'm going to go to example 5 because it's a word problem. I'm going to go to example 5 because it's a word problem. Is that one not working either? Yeah. Oh, yeah. Just throw it away. Sorry, they're old. They're absolutely old. So you're not hurting my feelings if you throw them away. I promise. Oh my gosh. Sorry. It's coming back on. Okay. Heads up. Come on. I need someone to read this because my throat is really sore. I need a reader, volunteer. You're awesome, Justice. Go ahead. Perfect. Okay. So this is a typical problem and it's a little difficult because there's a lot going on here. So I want you to think about, let's first of all talk about what are we doing? We're trying to figure out how many hats and jackets they can buy. So let's let X equal the number of hats. We're going to let Y equal the number of jackets. And it says they have a budget of $1,500. This is a cost. So this budget is going to be paired up with this cost right here. So how much does a hat cost? $5. So $5 for each hat, 5x, plus how much does a jacket cost? $8. So $8 per jacket. And we can't go over budget, right? We can't go over. So what inequality symbol can I use? Guys, heads up. Heads up. What inequality symbol can I use to represent that I'm not going to go over 1,500? Less than or equal to. Good job. Okay, so we took care of that one. It says they want to order at least 250 items. That means that the number of hats plus the number of jackets has to be greater than, at least is greater than or equal to 250. Okay. There's something tricky in here, though. It says they must buy at least as many hats as they buy jackets. What does that mean? Well, it says they need to buy at least as many hats as they buy jackets. So can they buy more? At least means they could buy more. So that means that X, the number of hats they buy, has to be greater than or equal to the number of jackets. Okay. So this one has 3 inequalities. This has 3 inequalities. All right. So if you have a filled out note, like if you have filled out notes, when we filled these out last semester, we didn't write this one down as our inequality. So you want to add these. So this first one, we're going to solve for Y. We're going to solve for Y. So let's see, 5x plus 8y is less than or equal to 15. What does that look like in terms of solving for y? What do you want to do? Subtract 5x from both sides. Oh, this should say 1500, yes? How did my zeros get gone? Did I erase part of those? This is 1500. Did I never even write the 1500 out? Oh my gosh, I'm so sorry. I'm so sick I can't even think. My brain is not working. All right, so 8y is less than or equal to negative 5x plus 1500. Next, divide everything by what? 8. Divide everything by 8. So y is less than or equal to negative 5/8 x plus, what's 1500 divided by 8? What is it? 187.5. Okay. Can we do something really fast? So we haven't yet talked about using Desmos for graphing inequalities systems, just because I wanted to make sure you knew how to actually graph inequalities first. So what if I were to put these inequalities that we wrote into Desmos graphing? So I want to show you what that looks like. I'm going to split my screen so we can do kind of both. Okay. So here we are. So I'm going to take all three of these inequalities that are written in black, and I'm going to input them into Desmos just the way that they're written. So 5x plus 8y equals 15, not equals, is greater than or equal to. And when you're using Desmos and you want to get to the inequality symbols or whatever, you have a keyboard down here. Of course, you can't see it because my screen is minimized, but you have a keyboard option. It's not popping up because that would just be too easy. That's all right. Huh? So greater than 1500. Greater than equal. There we go. I just hit greater than equal to 1500. So that's my first line. You can't see it yet. My second inequality, x plus y, has to be greater than or equal to 250. And then this one is less than, sorry. Is that what someone said? It's less than? I heard someone say something. You got to talk loud to me. I'm sorry. And then x is greater than or equal to y. So I'm going to mute the first two so you can see our solution set. So this is my first inequality right here in pink. And then when I plot the second inequality in blue, I just have this little solution area right here. And then when I plot the last inequality in green, it's this line. So the place where they overlap, the place where all three colors overlap, is this triangle right here. Do you guys see that? It's this triangle right here. Okay. So if the club buys 150 hats and 100 jackets, will the conditions be satisfied? Well, let's just see if the ordered pair 150, 100 is in our solution area. And it's not. So no, all the conditions will not be satisfied. All right. So from looking at homework and just walking around the last couple of days, I would say that our strength is, or maybe not our strength. You guys are good at muddling through stuff, but I think that we're weak on graphing, or you just don't feel super comfortable graphing. So if you want to use Desmos to help you today, you can. but you still have to draw them out. And the other thing is, I just want to make sure that you are not only using Desmos, but making sure